Okay guys, so we are continuing the previous class by this example that we had from the previous class. So we saw that if we know the position of point P with respect to the frame N, and after the N rotation you can find point P with respect to reference coordinate frame as like this: 1r0, 2 respect to 1, 3 respect to 2, and finally n respect to n minus 1 p1, that we established together from the previous class, remember? Now let us do this example, guys. Example, right? Example is this. First we are doing r y0 and phi, and then we are finding 2 r of new frame z1 and theta. That's right. Let us do that together. So this is what we are doing. This is our reference coordinate frame, x0, y0, and the z0. So we are rotating around right hand rule with respect to the y0. So first is number 1. So for the angle of the phi. So if you do that, what you get is this, right? Angle of the phi. So z rotates here, right? And the x rotates here, right? Here we go. So z1 and x1. Then I'm doing number 2. So this is if this is z1 and then x1, right? So I'm looking for the angle of theta. Here we go. So, and this is again your reference frame. This is your reference frame. Here we go. X0, Y0, and the Z0. So after rotating this around the Z frame, you're gonna have this x2 and y2. That's right. Wait, and here is 1. So I want to know after 2 rotations what I have. So obviously, based on this formula that I found, we get that the total rotation gonna be r y0 and phi multiplied by r of z1 and theta, based on this. So if you calculate one by one, because 3D rotations, so here you see that directional cosines, that's right. So x1 with respect to x0 gonna be how much? Here gonna be here gonna be phi, and here gonna be phi. So here you're gonna have cosine phi, that's right. x1 with respect to x0, y0 is 0 because this is normal, and with respect to z0 it's what? It's minus sine phi from trigonometry, that's right. Now y1 is fixed because we are rotating around the y0. So y1 with respect to x0 is 0. y1 with respect to y0, because they are parallel, so it is 1. And y0 with respect to z0 obviously is again 0. Now z1 with respect to x0 you can see here, it is what? Gonna be sine phi, right? So z1 with respect to y0 gonna be 0, and z1 with respect to y0 gonna be in this direction, minus. So sorry, respect to z0, respect to y0 is 0, respect to z0 gonna be this cosine phi, right? Huh? Now let's go to these rotations. So if I do that, let me see if it's recording. Yes. So now you have to find x1 with respect to x2 with respect to x1. You are rotating for the angle of theta. Here we go. Here is theta, and here is theta. That's right. x2 with respect to x1. That's right. So gonna be cosine theta. Cosine theta. x2 with respect to y1. Gonna be how much? Yes, obviously sine of theta. And x2 with respect to z1, obviously because at the normal plane gonna be 0. So y2 with respect to y1 gonna be, as you can see here, how much is that? Sorry, x2 with respect to y2 with respect to x1 gonna be what? Look at here. See, minus this value, minus sine theta. Oh, what is that? Okay, so let's see what happened. Hold on. Okay, it's back. Okay, now it's fixed. And 0 and 1, right? So I'm skipping how to multiply because it's trivial, and this is the result that you get after 2 rotations around the current axes. So this is the result. Cosine phi, you can do it home. Cosine theta, sine of theta, minus sine phi cosine theta, right? Minus cosine phi sine theta, cosine theta, and sine phi sine of theta, sine phi 0 cosine phi. Here we go. After 2-time rotation around the current axis, this is what we get. So now let me do this. Now this time I'm saying first, the example continues. First, rotate about z for the angle of theta, and then about axis y for phi. So we are reversing the rotations. So I'm naming this time as r prime. R prime. So this time gonna be rz first for theta multiplied by r, y, and the phi, right? So if you calculate this, here we go, right? Look at here, guys. Let me plot it for you. This is XYZ reference coordinate frame, right? X naught, Y naught, and the Z naught. Now we are rotating around Z for the theta first. So this is the new coordinate system, the first coordinate system that you get. Around Z, you're gonna have this. It's gonna be what? X1 and the Y1. Here is theta, and here is also is theta. So the rotation matrix gonna be x1 with respect to x naught gonna be cosine theta, x1 with respect to y naught gonna be sine theta, x1 with respect to z naught is 0. y1 with respect to x naught, c, gonna be minus sine theta, y1 with respect to y naught gonna be cosine theta and 0, and obviously 0, 0, 1. This is 1. That's right. Now if you rotate respect to and the y with respect to, see here I'm changing phi, so this we're gonna rotate around the phi, right? On phi. So you're gonna have now again z2 and x2, right? So your rotation matrix gonna be, for God's sake, it is so x2 with respect to x1, and here is phi, here is phi, and here is phi. That's right. So x2 with respect to x1 gonna be cosine phi, x2 with respect to y1, because its normal is 0, x2 with respect to z1, right? Respect to the z1, here we go. Z1, z1 gonna be minus sine phi, obviously. That's right. And if you can develop the rest, I'm just skipping sine phi, 0 cosine phi. Because this happens because we are rotating around the y1. That's right. Okay. Okay. So if you do the calculations, guys, I'm skipping the multiplication, and you get what this cosine theta, cosine phi, sine theta, cosine phi, minus sine phi, minus sine theta. I have the result. Cosine theta, 0, cosine theta, sine phi, sine theta, sine phi, and the cosine phi. This is what we get. So see, we reversed the sequence of the multiplication or rotation. So compare this, the result, with this. The first conclusion is that R is not equal to R prime. If you reverse the direction of the rotation, you don't get the same result, meaning that the rotation is not commuting. That's right. It's not commuting. You cannot say that I'm changing the reverse of the rotation and get the same result. This is a point that you have to notice, right? So after learning that we are rotating around the current axis, these examples and this formula that we developed, this formula is for rotations around current axes. That's right. So now let us try around so rotations with respect to a fixed or reference frame. So what does it mean? As its name implies, here we go. This is x, y, your reference coordinate frame. X naught, y naught, and the z naught. So what we are doing, we are rotating first around the y naught for the angle of the phi. It gives us this, right? Z1 and x1, right? This angle is phi and this angle is phi. Understand? Plus the next rotation, okay, is this, and this. As I will teach you later, today or the next class, this happens for the Roland, pitch, and yaw rotations. X naught, y naught, z naught. Now I'm rotating around again a fixed frame, this time z, and for theta. So this is what you get, right? Here we go. X1 and the y1. This angle is theta, this angle is theta. Plus, say the third one, oh, let me do this again. Oh, no. So this is going to be hold on. Okay, this is going to be your x naught, y naught, and the z naught. This time we're going to rotate around which axis? Yes, around axis x. I think not this. 41. 2 is enough. Okay, so this kind of gives you this rotation, guys. This kind of gives you this rotation. See, this is equal to this x naught, y naught, z naught. X naught, y naught, and the z naught. That's right. And this is what you had already. See, x1, z1. See, x1, z1, and y1, and then you had what? x2, right? Here we go. So you had this is 2. So you had x2, that's right, and y2, that's right, x2, y2, and that's it, right? And z2 that is parallel to this, that's right, x2, y2, and this is z2, right? So we want to make a rule for this. To get these rotations, this rotation we need to multiply the successive rotations made in the reverse form. This is the rule. It means that your final rotation gonna be, this time we are doing from the last one. We are going this way. Okay, so it's gonna be r of z and theta multiplied by r of y and phi. Remember, in these examples we were doing forward. That's right. See, r of y and phi, because we were doing around the current axis. That's right. And then z and theta. But if you are doing around the fixed coordinate frame, you have to go backward. This is the rule. Okay, this is the rule. So in the rule picture, I'm gonna teach you. Okay, this is the difference between them. So let us summarize until this point. Okay, so one is successive rotations around current coordinate systems. We have to do forward r1 multiplied by r2 multiplied by r3 to rn. Two successive rotations around fixed coordinate system or frame. You have reverse. You have to say Rn multiplied by Rn minus 1 and R3, R2 and R1. This is the only major difference between these two types of rotations. So look at here. You have to just look at here. Here we go. Okay, we established that. Is recording? Yep. Okay. Now let us, maybe you heard that in the robotics you have to know it. You have some famous rotations and the angles. One of them is Euler angles. It is a common method of defining a rotation matrix, in terms of three independent quantities. Okay, so this is another way of that you have rotation matrix around this. So how is that? So suppose that we have x naught, y naught and the z naught. So this is x naught, y naught and the z naught. The third angle that in the Euler angles that we are rotating we are rotating around the z-axis for the angle of the phi. So when we do that, we get xa and what? Ya, and this is za because we're rotating. Then this is first angle. So second is again is so this, if this is xa, xa, and ya. Let me have to redraw it because let me do this because I want to be consistent. So here we go. So if this is, so let me put this as why not like this for simplicity. Okay, so after rotation this is gonna be ya. Okay, we are rotating, so it's gonna be ya. So this angle is phi again, and this angle is phi. So right after rotation. So now the second rotation. So if this is xa and the ya, that's right. And if this is za, so we did that. So we are rotating around now ya, angle of theta. So what we get is, let me change the color to, I don't know, green. So you're gonna have, see, xb, and zb. That's right, zb. So here you're gonna be again theta, here you're gonna be again theta. That's right. Now the third one, that's right. So if here is zb and here is yb also at the same time. So and xb, zb, xb, and the yb that we had already. Now again we are rotating around again z, the new z. Here we go, for the angle of psi. So if you do that, you're gonna get this, that, you get, say, x1 now, y1 and z1 because you're rotating. So simply, if I want to make it short about all the angles, we name it rotation on z, y, z. So for simplicity, we are memorizing like this: z, y, z. This is the Euler angles. Very important way of memorizing what are the Euler angles. Z, y, z rotations. Okay, we say z, y, z. Z, then we are rotating the new y and then new z. Z, y, z. So Euler angles are consistent with which definitions? These definitions, because we are rotating around what? The current coordinate system. That's right. So the result must be forward rz and phi, ry and theta, rz and psi. Understand? Clear? Again, because we are rotating the Euler angles based on the current axes, so we have to implement this formula. So on the other hand, right, on the other hand, r1 with respect to the fixed coordinate system, because finally this is 1, that's right, with respect to x0, y0, z0, you have to do forward. So we got the R, Z, and phi. Get here. R, Z, and phi. R, Y, and theta. R, Y, and theta. And R, Z, and psi. Forward. R, Z, and psi. Right? So obviously, now I think you can derive these rotation matrices. So our Z and phi, obviously, if you're gonna have in this 0, 0, 1. Now you know it, that's right. XA respect to X naught, cosine and sine. So gonna be cosine phi, sine phi, obviously here is 0. So now y is minus sine cosine, that's right, minus sine phi, cosine phi, and obviously 0. Now rotation with respect to this, respect to y, so xp respect to xa, cosine sine 0, obviously again. See here. The cosine, and this is 0 because it's normal, cosine and minus sine, that's right. So cosine of theta 0 minus sine of theta, that's right. Obviously 0, 1, and 0, rotation is around y. And z is sine plus sine, cosine, and 0. So it's going to be sine of theta 0 and cosine of theta. And finally, the third one, obviously, it's going to be 0, 0, 1 again, 0, 0, 1, because we are rotating around the z-axis, right? Z-axis. And now here going to be again psi and the psi. So sine, cosine again. So it's going to be cosine, oops, hold on guys. Cosine psi and the sine psi 0, obviously. And now it's going to be minus sine psi, cosine psi, and 0. And the final rotation using the Euler angles, the result after multiplication, I have the result. Gonna be this huge but independent rotations like this. Gonna be cosine phi, cosine theta, cosine psi, minus sine phi, sine psi, right? And now sine phi, cosine theta, cosine psi, plus cosine phi, sine psi. And here is minus sine theta, cosine psi. See the first row? Second row is, second column is minus cosine phi, cosine theta, sine psi, minus sine phi, cosine psi. Here is minus sine phi, cosine theta, sine psi, plus cosine phi, cosine psi. Here is sine theta, sine psi. And the third column gonna be cosine phi, sine theta, sine phi, sine theta, and the cosine theta. And this is based on, because we are going forward, a multiplication of the three independent Euler angles. And this is the result. Let me see. It's recording. Yeah. Okay. So after doing this, let me introduce another one that we name it as roll, pitch, yaw. And this is very famous in your car motion. So I'm pretty sure that you heard this in the dynamics course, but here we are going detail. Roll and pitch, and yaw. Angles. How we define them and how we get the rotation matrix based on this definition. So let me show you. So this is hold on guys. So this is look at here, this coordinate system. So this is first is 1. I'm defining at this rotation. This is yaw. If this is the body of your car, guys, for example, let me show you. If this is body of your car, for visualization, that's right. So this is coming out of the body of the car. So I'm rotating. This is yaw. This is yaw angle. So we name it as psi. So this is yaw angle. Like as that your car is dancing, yaw. Okay. So the pitch is around this axis, right? And the theta. This is like at the frontal dancing of the car over the wheels, right? So this is number 2. I'm saying as pitch, and this is the lights of your car, and this is, let me do like this, and these are the wheels. And finally the roll is this number 3. Number 3 is the roll and for the angle of phi. So yaw, roll, pitch, right? So okay. So if I ask you how to calculate the final rotation matrix and which of them is valid for your car, for example, you have to say number 2. Why? Because you are doing around the fixed coordinate system, fixed frame, not the current frames. That's right. So this is a very important difference between the roll, pitch, yaw and the Euler angles. Understand? So is it recording? Yeah. Understand? So despite Euler angles, roll, pitch and yaw are around fixed frame, and therefore we have to use the reverse form of rotations. That's right. So if I want to say what is final rotation with respect to z, with respect to the fixed coordinate system, it's gonna be, it's the 1, 2, 3. You have to go back. You have to say if this is x, y and z, that's right, you have to say 3, 2, 1. So we're gonna have r phi, sorry guys, z and phi, then number 2 are y and theta, that's right, and then number 1, it's gonna be our x and psi. Understand? So if you extend all of them, So RZ respect to the phi, you get this. I'm just skipping because now you know I want to save the time. You can derive this by yourself for practicing. Cosine phi and the z and 0, 0, 0, 1. Ry is going to be cosine theta minus sine theta 0, 1, 0. Sine theta 0 cosine theta. Now these are now trivial for you because you know how to find the directional cosines. This is 0 cosine psi sine psi 0 minus sine psi and the cosine psi, right? So that's it. So, and the result, I'm ending right now. So the result of that roll pitch rotations, because it's respect to the fixed coordinate system, R1 respect to 0, gonna be another huge rotation matrix that I have the result. Gonna be cosine phi cosine theta, sine phi cosine theta, minus sine theta, minus sine phi cosine psi, plus, this is psi, plus cosine phi cosine sine, let me do it correctly, sine theta, sine psi, here it has cosine phi cosine psi, plus cosine phi sine theta sine psi, here is cosine theta and sine psi. Here we have sine phi sine psi plus cosine phi sine theta cosine psi minus cosine phi sine psi plus sine phi sine theta cosine psi and cosine theta and cosine psi. That's right. So, and this is that we have these famous rotations. So you have to distinguish that if you are rotating around the current axis, you have to go forward rotations. If you are doing rotation around the fixed coordinate system, so you have to go reverse or backward rotations. So that's it. Until next class, guys.